Namaskar. Welcome to Prakash on Basics. I'm Prakash Zog. A friend of mine asked me how radios work. That's pretty interesting. So I thought I'll talk on that because many of us have used them and need to know really what happens. In general, this is typically referred to as radio broadcasting and reception. The unit that we have at home is typically the one that is called as the radio. Let's understand the background first. If I talk, uh, the sound travels up to a certain distance. But all this has a limitation. It can travel only up to a certain distance depending upon the amount of energy that I spend. And the waves that are produced are typically known as longitudinal waves. They die out after a certain distance. They propagate through air. I'll go into details of these waves sometime later. These are typically mechanical waves. Uh, and this is how sound propagates from one point to the other. But if I'm supposed to carry the sound to a very large distance, so maybe up to Delhi or up to USA or some other areas, I need to use different methods. And so what you use is known as the electromagnetic waves. Actually, this is a very big area, but just realize that light that we talk of is electromagnetic waves. Many of the signals that go around for TVs and radios are all electromagnetic waves. There are certain types of telescopes that use electromagnetic radiation and so forth. We'll go into details again sometime later. Right now, just remember that there is an audio wave by which I am talking, and there is an electrical wave known as the electromagnetic wave that I'm going to use to help me out in sending this sound at other places. How does this happen? Let me take an example. Keep this example in mind as I proceed afterwards. Suppose I'm invited for a marriage in Delhi uh, on a particular date, maybe 2, 3 days from today. So, how do I go there? If I start walking, I might reach maybe after their child is born. So that's out of question. So I can't really travel in that manner. So what do? I get out of my house, get into a vehicle. Let's say the vehicle drives all the way up to Delhi, and I reach there on time. And because I'm supposed to walk into a marriage pandal, when I go in, I have to leave the vehicle outside. I can't, just because the car has come all the way with me from Pune, it doesn't mean that I take it into the pendal in Delhi. So I leave the car outside, go inside and attend the function. In all this situation, I am the audio signal, and the car is the one which has carried me all the way from here up to Delhi by a different mode of transport. And that is what is a carrier wave. And once I reach that particular point, I can't take the carrier wave inside. So I leave the carrier wave outside and I get inside as the audio signal. This is typically what is going to happen when the radio functions. Okay, let's look at it from the actual perspective of what happens. We know that there are a variety of radio stations. Each of them has have their own carrier wave frequencies of electromagnetic waves. They lie in a certain range, which is typically referred to as, I'm sure you have heard of the words uh, medium wave and short wave and so forth. So there are regions in which these waves are selected, and they are the ones which are used to carry the audio signal. And every radio station has its own typical carrier wave frequency by which the radio station is identified. Okay, now let's look at it from a different point of view. Suppose I'm to broadcast a particular song which is to be heard everywhere around. So I go into the radio station, I stand and start singing, but what I'm doing is producing an audio signal. It has to be converted. So what are the steps that take place? I first walk into what is typically referred to as a recording room, a place where there is no other disturbance and only the recording of sound can be carried out. This is what happens at the radio station's first point. So I begin to sing. But that's of no use because that's still a longitudinal wave. I sing in front of a microphone. Micro is small, phone is associated with sound. It's a typical device that converts my audio signals into electrical signals of the exact same nature, but now they are electrical impulses. How microphones work is a different issue, but let me just remind you that there is a diaphragm or a plate, and when I sing in front of it, it vibrates. These vibrations in the plate are communicated to a coil which vibrates in a magnet, and the magnet interacting with the coil moving produces an electrical signal which goes through a small set of wires to wherever I want to. This is how my audio signal that I am singing is converted into an electrical signal. But as I said, it's micro, so it's too small, so it has to be amplified. So what you do is you amplify it. For that, you use typically what is known as an amplifier. An amplifier is a device that makes the signal more powerful, more energetic, bigger in size, and so forth. But the quality of the signal remains exactly the same. So it can't happen that I sing a song and the voice is of a good quality like Muhammad Rafiji. That doesn't happen. Whatever is the signal just gets amplified. Uh, Typically, let us say I have a scale of this sort. This is how an amplifier works. When I vibrate things here, this is small, and what happens here is much bigger. And that's how amplification really takes place. And so the signal is amplified. That is not enough. So what do? The radio station has its own carrier frequency. It's much higher. When I talk in terms of what is known as kilohertz and so forth. The carrier frequency, which is an electrical impulse, is much, much higher. And on top of it, you put this audio signal's frequency that has been converted into an electrical pulse. This process of making it sit on top causes the pair to change, both of them. And this process is known as modulation. So the original carrier wave gets modulated. It's based on what is known as principle of superposition. Let's keep that aside. Let's take a simple situation. There's a horse that's galloping around. So if so somebody else looking from a far distance can see the movement of the horse. Now, an old man, rickety old man, sits on top of the horse, and his neck is moving, and the horse is also moving, and both the motions are observed by a person far away. So if he concentrates on the nose of the person, it is affected by two things. One, the motion of the horse, and second, his own rickety motion of his neck. So this is exactly how the wave gets modified. And this process, as I told you, is known as modulation. So sound gets modulation. But the modulation can take place by two methods. One is its size can become big or small, and that is known as amplitude modulation. And there is a second process in which the frequency of vibration itself changes, and that is known as frequency modulation. And we know of this also because we have nowadays FM stations. That FM station is nothing but the frequency modulation. And so now what I have done is I have created a modulated wave, amplitude modulated or frequency modulated, depending upon how I want it. Now the next step, it has to be sent out. So it's amplified much more. And then through an antenna of the radio station. It is transmitted all around. These electromagnetic waves travel at the speed of light. They're extremely fast. 3 into 10 raised to 8 meters per second. That is 3 lakh kilometers per second. This is the way at which they speed at which they travel. So the wave begins to travel. Where does it go? It can go into space. But outside Earth, there is a particular layer, and that layer is known as an ionosphere. This is a layer of charged particles. And the waves cannot penetrate through that ionosphere and go out, but get reflected. So the wave gets reflected. So it comes back, it hits the ground, but the ground also reflects it. So as a consequence, if this is the earth, the wave starts from one point and goes round, 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 and starts going everywhere around. And within a fraction of a second, the waves have propagated everywhere around on the earth. Their signals and their quality is the same, but its strength is going to be pretty weak. It also depends upon the transmission energy of the radio station. And I'm not and this is not the only place where transmission is being made. So there are thousands of radio stations which are transmitting simultaneously and sending out all these waves, and the whole space is filled up with all this. Now, the next step. I'm singing. So my daughter, who is in the US, wants to listen to this particular song. So she takes up a radio. This is the radio receiver. And she needs to collect that signal. So what does she do? She uses a wire. And if you remember, in olden days, many of us who have used radios had an aerial that used to be connected, and an earthing also. And this is the antenna on which the radio signals fall. Being electrical conductors, they are connected to the radio input point. Now the signal comes in, but there are thousands and thousands and thousands of signals. So what does she do? She turns a dial and adjusts the pointer on a particular radio station. What it does is, inside there is a circuit consisting of an inductor and a tank and a capacitor. It is typically referred to as a gang condenser. I'm just giving you the names just if you have heard of them. And that's what happens when you turn that knob. And this tank circuit has a capacity to oscillate at one particular frequency that is selected. So she selects the frequency at which my carrier wave is coming. And so that is the signal that is taken inside the radio and amplified, and the rest of them are cut off. This process is known as tuning that we typically know of. So she is using a tuner and adjusting to this. Many of my friends who have used radios would remember that there was a method of detecting whether the tuning was done using what is known as the magic eye. There used to be two lights, and once they used to merge, yes, the radio station would have its maximum frequency, rather maximum sound level. And that's how the frequency comes in and gets inside the radio. But it's very, very, very weak. So what do? You amplify it once, twice, 10 times, 1,000 times, and make it sufficiently big. But it has both the carrier frequency and the audio frequency that is put on top because of the modulation. So it has to be removed, like the car that was left outside, I told you some time back. So what do? You use another circuit known as the demodulator. So it removes the carrier frequency and retains only the audio signal. And that is the one that is taken in. The carrier frequency is discarded, that's of no use. Once this audio signal comes in, you amplify it further and you raise it further and further and further till it comes to a desired level that we are interested in. And then it is given to a loud speaker. The word itself is very clear. It is exactly opposite of what we talked of in the case of microphone. The electrical signal goes to a coil, and the coil is placed within a magnet. And because the electrical signal within the coil is fluctuating, the coil begins to fluctuate, and the plate attached to it begins to move, and the plate is moving at the same frequency that I have talked of. And so the same sound is produced once more, and it's amplified because it's a loudspeaker. And so my daughter can hear the voice that was produced by me in one radio station. And that's the set of processes that would happen whenever a radio functions. There are, as I told you, microwaves and radio waves and gamma radiation and so many different types of radiation that are around. It is the selection of this radio frequency range that we talk of today whenever we talk of radios. And that is selected, sorted out, amplified, and presented wherever it is required. So when she changes the dial, she can tune on to some other radio station. So today, many of us remember that there used to be transmission from Ceylon radio, and we could hear it. And Voice of America could be heard in India, and you could hear Moscow radio or BBC, and all these radios were functioning on the same principles because of the multiple reflections, and there is hardly any time lag because the speed is extremely high. So the information pass on from one point to the other very easily. So this is how a radio works. Sound, energy in audio form is made to sit on top of an electrical signal, transmitted out, received, the carrier frequency is kept out, the audio frequency is taken in, modified, amplified as required, and heard once more. Exactly identical to the original sound. As I told you, the time lag is negligible. There is an international telecommunication union in Geneva, a part of United Nations, which controls all the frequencies that are used by a variety of systems. Mobiles and others also use similar methods. We'll talk of that sometime later. The medium wave radio frequencies that I mentioned, the wavelength is about 1 kilometer to 100 meters. That's the medium wave frequencies. It's around 300 kilohertz to 3000 kilohertz. And then you have high frequency HF. Uh, this could also be referred to closer to your shortwave ranges. And then you have what are that is about 100 meters to 10 meters, the lower block, and so forth. So there are many such ranges in which radios function, radios and many other devices. And all of them use basically the same principles of working. This is how radios work. So next time you tune in to Voice of America or BBC or any radio station, realize that that's how everything has been functioning. And if you're traveling through a car, you have a car radio which usually tunes on to the FM, the frequency modulated type of a radio station, which is more clear, more crystal clear, but it has a limited range. Why is something that we will talk of sometime later on. So you have either amplitude modulation or frequency modulation, and all that gives us the beautiful songs that we like, the beautiful lectures that we like to hear, and so many other things. That's one device of telecommunication, radios. We also have the TV and we have the mobiles and so many others. Those maybe I'll talk of sometime later. If you've liked whatever I have said, please like and subscribe to this channel. Tell your friends, tell them how modulation takes place and how radios are heard and how signals go from one point or one end of the earth to another end. Till we meet again on some other topic in science once more. Namaskar.